everyone. So in today's video, I am gonna discuss this new contest that I took part in Codeforces Round. It's 772. So there is still some time left, but I know I'm not gonna get any problems moving forward like D, E, F, like they are out of my level. So yeah, let's discuss each problem. So the first problem says min or sum. So the problem states something like this. If you're given an array, let's say 1 3 2, now you need to minimize the sum of this whole array, and the only operation that you can do is you can replace two numbers in this array with two numbers x and y if this relation satisfies, like if ai or with aj equals to x or with y. So if this relation is maintained, then you can replace ai with x and aj with y, right? So for example, in this case 1 or 3, which basically gives us, I think, 1 on 3 0 1 1 1, which will give us 3, right? Similarly, if I had done 1 or 2, so 0 1 and 1 0 would have given me 1 1, right? So this equation is satisfied, so I can replace 1 with 1 and 3 with 2. So now my new array becomes 1 2 2, right? This is my new array. So the sum has been minimized. You can see that here the sum was 3 plus 2 5 6, and here it has become 5, right? So we need to do something like this. So this is the problem statement. Now the catch here is, if you observe, if there are no carry bits required, or if there are no carry bits involved, then if I take two numbers, let's say 1 and 2, so if I do a sum of 1 and 2, it's equal to 1 or 2, right? So if I have any two numbers, no matter what, like let's say 1 and 3, so obviously 1 plus 3 is not equal to 1 or 3, because 1 plus 3 has carry bits involved. If you see 0 1 1 1, so if I do bitwise sum, this will become 1 0, and this will become 1 0, so this is 4, right? But no matter what we do, the max we can reduce this array would involve the maximum bits set, right? Because at the end we are doing sum, so the maximum we can reduce any two integers of the array would be unsetting one bit here and there. But at the end of the day, if you take OR of all the numbers in the array, that is going to be our max possible answer that we can reach, right? Because we don't care about how many operations we apply, but we want to know what will be the reduced value. For example, let's take 3 5 6. So what would be the OR of this whole array? It would be 1 1 is the 3, 5 would be 1 0 1, and 6 would be 1 1 0. So if I take OR, it will be equal to 7. So you can see that 7 is the minimum possible value that we can reach for this array, no matter what operations you apply. Like obviously the sum here right now is 5 plus 6 11 3 14, but we can minimize this to 7, and you cannot go anywhere below 7, because this is the minimum bit set in using this whole number. So the answer to this problem was just taking OR of all the elements, and that would be your answer. I will share code of this problem in the description below. Moving on to the problem B. This was an interesting problem. So the problem states like, if I have an array 1 2 1 3 1, so I need to find local maxima. So local maxima would be this number and this number, because 2 is greater than both its neighbors, and 3 is also greater than both its neighbors. The ending elements cannot be local maxima because they only share one neighbor. So yeah, so what we need to do here is we need to change the local maxima to any number between 1 or 10 to the power 9 such that there are no local maxima involved. So let's say if I make this array as 1 2 2 to 1, then there is no local maxima, right? And how many numbers what did I was I required to change? So I changed, let's see, I changed this value, I changed this value. So in this case I changed two values. So this is what we need to minimize. We need to minimize the number of values we change, and also we need to print the array later on, right? So how can we approach this problem? So let's take the example again. So we see we have two local maxima here. The best strategy here would be, what if I had made this element as 3, the middle element. So now my array becomes 1 2 3 3 1, and you can see there is no local maxima here. So the number of operations involved here is only 1, and this would be my final array, and you cannot do better than this one, right? So how can we approach or reach the state? So what I observed, that if I have array like this, let's take something like, okay, so in this case we see there are two local maxima, one is this, one is this. Now if two local maxima are separated by more than distance of 1, like in this case, what is the case here, that we have 2 at index 1 and 3 at index 0 1 2 3 4. So there are two elements in between these two local maxima, so it doesn't make sense to change the in between elements, right? It the only way we can change is change these two local maxima to any number that is max of this neighbor. So here I make 2 as 1 because it's max of which what the neighboring values, which is 1 comma 1, and then I do the same for 3, and this is my final array. So my answer would be 2, and this would be my final array, right? And the reason I'm doing max of its neighbors, because what happens, let's say in this case, if I take something like this 3 2, okay, oh, let me remove this. Yeah, if I take something like this, now I have one local maxima, right? So what if I don't replace this with maximum of its neighbors, let's say I replace it with something greater than 3, obviously it will stay local maxima, so that doesn't help our cause. What if I take it as 1, so if I make this array as 1, so in this case it works, but let's say if I take some other case, something like 4 5, so in this case, no, I will make it as 3, or I'll make it as 2, right? Correct, something like this. So I was trying to get to the point that if I make this something like 2, right, then there is a chance which is like minimum of 3 comma 2. So if I make this element as 2, then my array becomes 1 3 2 2 2, but then this gives rise to this new local maxima. So the best strategy would be to go with the maximum value to replace, right? So there are two observations here. One is, if two local maxima are separated by a distance of 1, then it's better to replace this value with maximum of these two. So replace this with maximum of its neighbors, right? This is one case. Another case would be if they are separated by a distance of more than 1, like you can say. So in that case we can't do anything, we no need to replace any two, we can just replace these two equal to max of its neighbors, and our answer will be 2 here. So this was the approach for second problem. Moving on to the third one. For the third one, there was a nice observation that I saw. So first let me explain the problem. So in this problem what we need to do here is, let me take an example. Yeah, so in this one what we need to do here is, if I have an array, let's say, right, so I have to pick three elements, which is x, y and z, and such that x should be less than y, should be less than z, right? So obviously if I have to change this number, let's say number 5, which is at index 0, so I need to pick two numbers, so the y should be greater than 0, and then if I pick y as 1, so y is 1, so in that case z has to be greater than y, so now z has to be any number between this list. So z can take any value, y can take, obviously y can take other values also till this end, but just for the example purpose I am taking it as -4. So this is what we need to do. Now one observation here is, when we take three numbers and where x has to be less than y and y has to be less than c, you can see you will never be able to change the last two values, which is last two values -1, 2. If they are in non-decreasing order, we are good, but if they are not, then our answer is not possible. So answer will be -1, because we cannot change last two elements no matter what happens to the rest of the array, right? So one observation here would be that if we know we cannot change the last two values, we obviously first check whether um, these two are in non-decreasing order or not. If they are in non-decreasing order, wouldn't it make sense to greedily replace all other previous elements with difference of these two, which is -1, -2? Let's say in this case it will be -3, so my array becomes -3, -3, -3, 1, 2, and you see this is in non-decreasing order, and I did it in n-2 operations. And the problem also states that you have to maximum operations you can use is n. So obviously using this we will never exceed n, because we only need n-2 operations, and you can see you don't need more than n-2 operations to actually make this non-decreasing, if it's possible. So the problem here states that only that you need to replace any number with ay minus az. So as I said, now one condition is clear, that we need the last two elements to be non-decreasing order. Right, now there is another case here, there are negative numbers involved. So what I do here is, I take a table yz. If both numbers are positive, what combinations we can make? If this is positive negative, if this is negative positive, and this is negative negative. Okay, so first we'll come to this case, negative positive. In negative positive we see that it's already in non-decreasing order, and the difference between ay minus az will be less than ay or az, right? Because let's say if it's -1, 2, so it's -1 -2, it will give me -3. So it will always be less than ay and az, right? So no matter what, my answer is always possible in this case. Correct. Now we take a case of positive negative. In positive negative, what will happen, that already the last two elements are not in non-decreasing order, so this is not possible. So if this case happens, then we just do it -1, right? Now with plus plus there is a catch. If with plus plus, if the numbers are like this, 2, 4, right, in this case this 2, which is my y, is less than 4, so this is fine, because 2 minus 4 will be giving me -2, so all the numbers before n-2 will be -2, and then it follows non-decreasing order. So in positive case we have two cases. If ay less than, sorry, Yeah, I was right. If ay is less than az, then answer is possible. If it's ay greater than z, then not possible. Similarly, with minus minus, we'll have two cases. In minus minus, what we need to do here is, if we have minus 2 minus 4, what does the difference give us? It gives us 2. So this is not right, because 2 will give me a, like, numbers before n minus 2 which will be greater than my n minus 1 and n minus 2 number. So in this case, if y is greater than z, right, ay is greater than c, um, we can actually say that minus 2, yeah, we cannot make it work. If it's y is less than z, then let's see what happens. If it's minus 4 and minus 2, again minus 4 and minus 2 will give you a minus 2 as the answer, but minus 2 will again become greater than minus 4. What I'm trying to say here is, let's remove this. Let's say if I have minus 4 minus 2, right? So if I have a list like this, 3 comma minus 4 minus 2, so minus 4 minus 2 is obviously not in decreasing order. So in case of both the numbers negative, it's never possible. Only if it's possible if it's already in non-decreasing order. By that I mean is, if it's like minus 3 minus 2 minus 1. So in this case, both the numbers are negative. Ay is less than az, right? And we don't need to do anything, no operation, because it's already sorted, like in non-decreasing order. So this is our solution. So in case of minus minus, you would need to handle that case individually, but overall this is the approach. Look for the last two numbers and you will get the answer. So this is how I solved the problem C. I saw problem D, but I wasn't able to come up with a solution, so I didn't give time there. Hope you guys had a good contest. If you guys like this video, subscribe to my channel, give me a thumbs up, and follow me on Instagram. Thanks everyone.